Hi everybody, this is Tiger Meat. This is my second try of recording this because I goofed everything up. I'm going to be showing y'all how to set up a local training environment for DiffSinger on Conda on Windows 11. Should work on other Windows, but I'm doing it on 11 because that's what I got. So let's get right into it. So first step you need is Anaconda 3. I have a bajillion different versions of it installed, so I would just say just install Anaconda if you don't have it installed. Follow all the everything that it recommends when you set up, and then you'll have kind of like a little thing Anaconda prompt. It's going to open a command line window, and you'll be able to use Conda out of here. I believe Conda comes pre-installed with Git. I don't know if that's the case. If it's not, I'm sorry. You have to figure that out on your own because mine already has Git, but it probably does come with Git already. Second thing you're going to need is just a folder, an empty folder on a drive that has a ton of free space, because DiffSinger local training or just training in general does take up a lot of space. Like an acoustic model can get up to like I think 500 megabytes, and a variance model can get up to almost a gigabyte, just the checkpoints alone. So you definitely will need a lot of space. And then of course some labeled singer audio, for training the actual voice. And in this step, in this video, I'm going to kind of cover a few of the configuration things, since a lot of the configurations on the notebooks are done kind of automatically by the notebook, whereas here you kind of have to edit them manually. So I would also recommend in that case that you have Sublime Text installed, because it's just really easy to read YAML files on Sublime. So without further ado, first step that we're going to take is actually setting up a Conda environment, like in the literal sense. So what we're going to want to do is change the directory to the folder we're going to use. In that case, I'm just doing local env setup. I recommend having no spaces in any of your file paths, as Python does not like that. So first step is to actually create the environment. We're going to type in the command conda create -n. I would just, the next thing you're going to put in is the name of the environment you're creating. I would recommend just doing DiffSinger or something similar. But in this case, since I already have DiffSinger and DiffSinger_2, I'm going to do ds test env. And then one other thing you'll want to add at the end of that to ensure we give it the right version of Python, we want to do Python equals 3.8, and that will just install the most recent version of Python. So this is going to take a minute or two to get set up, and I'll just cut this out. So this is what it's going to install. I would just hit Y. It's going to install everything. Might take a second. Cool. So now you're going to see, to activate this environment, use conda activate blah blah blah. So let's do that. Conda activate ds test env. And you'll know that it's working because before the file path that you are currently in, you're going to see the name of the environment in parentheses. So next step is that we are going to actually clone the repository for DiffSinger. And to do that, we're going to come to this page, open VPI's fork of DiffSinger, which is the one, which is the working one. Under code, this is what I do. You go to code, local, this one right here, click this button, and then go back to your command line window. I could just do that. And you're going to type in git clone, paste that in there. So what that's going to do is in the folder that you have selected as your current working directory, it will download and install this. We are also going to have to install some checkpoints. So actually, if we go to the OpenVPI page under vocoders, aha, there we go. So you want to come to this page and download this zip file right here. And then back in this one, oh God, I am struggling right now. So let's go ahead, extract this all. Boop, 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 boop. Checkpoints. So you'll take this folder, put it in the checkpoints folder. right place to do it, because I recommend using rmvpe for the pitch extraction method. So yeah, it'll be just rmvpe and then model.point, or yeah, checkpoint, whatever. All right, so that should be all the checkpoints we need for right now. I don't think there's any more. Nope. Okay, cool. So next step is going to be installing Torch. Now this is a Windows thing. pip3 isn't going to work. So I will just select everything after the pip3 initial command to run pip. And for those unaware, pip is just a tool that installs Python packages. So instead of pip3, I would just write pip and then copy paste the rest of it. It's going to install Torch for you. This is, if you try installing it with Conda, I get weird errors, and using this command is going to be the most effective way to get Torch installed successfully. All right, that only took about a minute to do, so it's not too bad. So once you get all of that installed, the next step is going to be to actually install the rest of the DiffSinger requirements. So we'll go ahead and do pip install. -R is for requirements files. It'll know to parse the text file. Requirements, requirements.txt. Oh, I did some wrong. Requirements.txt. Oh, I know what's wrong. I have to change the directory to DiffSinger. There we go. So then let's go ahead and go back up and do this, and it's just going to install everything. I don't think it's going to fuck with any of the Torch installs that we have. All right, so as soon as you get that installed, you are theoretically ready to go. There's a few other things we have to do, obviously, and the next step is going to be ensuring your data set up properly and also getting your configuration file set up and changing some of the things in there for the way that I kind of recommend to change them. So let us go ahead, and first step, I like to go to the data folder. This is where it's going to save any like binary data when you process the data, but it's also going to be a good place for you to keep your data set. So I would create a new folder and name it something along the lines of like training data. That's kind of what I do. And this is where you would put your folders containing the raw data for your speakers. I'm gonna copy paste 2 speakers from my general data set. Just as an example, right now I have 23 speakers, but I'm just gonna do these for now. So under data and training data, you'll kind of want it to be like this, and you want it to be set up this way for the sake of simplicity. So Tiger Fresh is Tiger's main voice mode, and inside you have a transcriptions.csv file as well as a WAV file. Generally, the way that DiffSinger users are creating their data is by doing it the N and SVS style with label files and WAV files. In this case, the data I'm using here has already been converted and edited for DiffSinger, but there's guides and ways to do that. So this is running under the assumption you have DiffSinger ready data. So in the waves file, you'll see that I have DS files, but it could just be waves in the segments. I used Uta's thing, and then the transcriptions file just has all the data that is the transcription. So I have Tiger Fresh and Triton Gale. And those are the 2 voice modes I have right now. So the next step will be to go to the configs folder, and I would do this. I would never change these files ever. I would just make a copy of the acoustic and variance configs, and then I do it where I kind of have a internal code name for my project. So TGM would be Tiger Meat, and then acoustic. So if we open up this YAML file, this is what we see. This is the base YAML file, and we're not really going to change much. We're just going to change the important things for training. Let's close that. Okay, so okay. First thing, base config. Don't change that. Task class. This is just saying that this is acoustic binarization. or training, the number of speakers is going to be the literal number of speakers you have. Most Python stuff is base 0 index, but in this case, this is a literal count of the number of speakers you have. It does get confusing because the IDs for these singers is going to be different because of this. So under training data, let's kind of just go in order. So the speakers we have here are tiger_fresh and Triton_Gale. For those wondering, the way you want to have this set up is in list format. There's a couple different ways to do it, but the most easily legible way to do that is by having 2 spaces, a dash, and then a space, and then the entry. And that's going to basically make it a list in a Pythonic sense. And the reason I recommend Sublime Text is because for YAML files, it'll automatically kind of have that, what's the word? I'm blanking. It'll automatically have that setup, the layout. The next thing we got to change here is test prefixes. I actually recommend moving this speaker ID one kind of away because this is going to be kind of the one you edit the most. I'm also going to copy, I'm going to copy and paste the raw data raw data directories. I would move that here because we have to make this a list too, the same way we made the speaker ones a list. So it's gonna be like that. And then test prefixes is for validation. This one's really important. And it kind of needs to be set up in a specific way. So in the configuration, we're gonna have $0. That's the index for Tiger Fresh. $1 is going to be Triton Gale. That's the index. And $sign in YAML is going to make a comment. So you can type something out and it's not going to be actually be read by whatever is loading this YAML file. So I recommend 5 validation files per speaker. Minimum would be 2, but you're just going to get better results with 5. You know, it's able to check more. So the way that this works is it's 0 and then, or the, here, let me write it in a comment. So it'll be the index of the speaker with a colon and then the name of wave without the dot wave. So what that looks like here in the sense of Tiger Fresh. So what I do is I go into the wave folder and I'll literally just copy one. So 0 and then the name of the wave file without dot wave because that automatically gets added. So I kind of just grab a couple random ones. You might want to grab longer ones and I check that by the size. You can also add length, but I'm not going to do that because I don't care. So for the intents and purposes of this video, I'm just going to do 3. And I also like to do this because it's legible and YAML is supposed to be human legible. So let's go ahead and do Tiger Fresh. And in parentheses, we'll do 0 because that's the index. And this is just, you know, for my own reference so I know what I'm doing. What you need, segment 0. So you have the test prefixes done. And finally, what we need to do is point the raw data directory in order in the data folder. So in this case, everything that is done out of the config file is in like the root folder of DiffSinger. So all file paths are relative. So in this case, we want in the DiffSinger folder, data, training data, and then these folders. So here all we have to write is data, training data, and then Tiger Fresh. And I would, in a comment, put 0 so that you can keep track of which index that is. And then data, training, data, Triton Gale. Cool. So that's that. Next thing to check is the vocoder. I wouldn't recommend doing anything but NSF-GAN for the validation. If you have a fine-tuned vocoder, you can use that here. You just need to have a generator checkpoint. I would recommend actually just using ML07's notebook for that because it might be a bit confusing to set up. I had to, copy some scripts and what have you. But honestly, this is the most important thing for your setup. If you're doing multi-speaker setup, have the same number of speakers, have all this right. Otherwise, for a single speaker, you don't need the index, I believe. I think it just knows. But I've actually never trained single speaker. So the next big thing I recommend is under binary data directory is to do something like data binary, and then we'll say this is Tiger Meat acoustic version 1. And that's going to be where it actually saves the data that you've binarized, which is cool. Next thing that I actually forgot is the dictionary file. So this data set that I have is for English, and under dictionary you just have the OpenCPOP guys. But I'm going to copy this over from my other one. This dictionary file is basically what the phonemes that are in the voice bank, and then a tab. I think it's a tab, right? Is it a tab? Pretty sure it's tab. It's tab. So tab and then the phoneme again. This could also work for like diphones, but I don't recommend it. It complicates things. I would just do it, monophonically. Is that a word? It can be. We'll pretend it's a word. So let's go back to, this one. So we just want to make it point to that dictionary file, and I recommend keeping it in the dictionary folder. Let's see, dictionaries tgm underscore dictionary.text. So that's basically it for this part. I wouldn't change anything here. I would change the F0 embed type to discrete. And if you're curious, what that does is instead of storing the pitch data as a single continuous line, it kind of splits it up into chunks. And I just feel that it trains better, and I've been told it trains better. If you're using multi-speaker, you do need to change use speak ID to true, and you may ask, Tiger Meat, what's this up here then? Why is it blank? Well, DiffSinger has it built in to where if the speaker IDs is blank, it'll automatically assign them based on the order. So yeah, just don't change it. I've tried doing it the other way and it doesn't work. Next thing is you'd want to change is if you want to use any of these embeds. I'm not going to recommend anything because everyone's a little bit different in what they like. So yeah, do what you like. I personally don't like using energy and breathiness right now, but I just have issues with them. But again, it's totally up to you. I wouldn't change anything here. Don't change anything. I would recommend using shallow diffusion. Don't got to change anything here. So next thing, you can actually change a couple things here if you'd like. For the L1 schedule arguments, if you want the learning rate to drop faster, you can lower this. There's really not a reason to do that. I would keep it where it is. When the learning rate lowers, from my experience and understanding, you get a bit of it kind of refines the model a little better, but it also lowers the scope of how much it trains. So it'll train more accurately and closer to the source material, but you will miss out on more general kind of things. So I wouldn't change that. With local training, you're going to have a little more issues with batch size for sure. The notebooks use 9 as the batch size. I tend to have the most luck with 16, but there is one extra setting that we actually have to add in here for that. And then I also like to keep 20 checkpoints at a time and change the val check interval to 1,000. That just means every 1,000 steps of training, it's going to validate. Adds a little bit more time, but I noticed it just kind of improves things. If it doesn't, I don't really care. That's just what I do. Cool. So, and then fine tuning, I don't recommend fine tuning unless you are training encoders separately, which is not something that I'm going to be covering right now. So this is actually, I'm going to add this up at the top. This is actually something that you would find in the base configuration, but because we don't want to change that, we're going to add it here. So PL trainer precision 16 mixed. This is a preference. For me, I only have 8 GB of VRAM, and I struggle to train anything higher than 16 batch size I can't go any higher than like 8 batch size on 32 true. And all of this is how much it's training at a time. So it's only training 16 bits of data at a time as opposed to 32. But with 16 mixed, I think it kind of wavers. I'm not 100% sure, so don't take my word for it, but I get very similar results if I do 16 or 32. The next thing here is PE and PE checkpoint. PE is going to be the pitch extraction method. In this case, like, I made the whole stink about installing rmvpe, and then we're just going to point to the checkpoint. I'll include this test YAML file, as well as a variance one, kind of notated, but I'm not going to go through that again because it would just kind of be, kind of a waste of time. So we're going to go ahead and save that. And once you get the configuration set up, you are ready to go. One thing I didn't touch on is data augmentation. I've never used it, and every time I've tried to use it, I've gotten errors on doing it with multi-speaker. So it's definitely a really good tool for single speaker models, as you get more out of the data you already have. But in this case, I'm not going to touch it because I've never really needed it. So we're going to go ahead and get out of Sublime after we save our configuration. Next step is actually getting the training going. So first we have to do the binarization. And from my understanding, that's kind of just like pre-processing, just a different word. So the command, and I've trained DiffSinger so much at this point that I have the commands memorized, which is silly. It's python scripts-binarize.py. We are going to just add the config, and it's configs/tgm acoustic.yaml. So what's going to happen, I hit enter, and it's going to give me a huge wall of text, and this is basically the configuration file being read back to me. Hold on one second. Okay, so this is actually a really interesting error right here that I will talk about. So the binarizer is not going to be able to run if there's any mismatches in the data versus the phonetics that are given. And these are extra phonetics that I added to my data set for other languages, but the voice modes that I have training in this instance don't actually have these phonemes. So how would you fix this? Quickest fix is to just remove them from the dictionary file. So boop, 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 boop. Where's RX? Boop, boop. Oh, wait, we need that. And then get rid of that one. Since this is a test, I don't mind removing it, but otherwise I would make sure that your data is labeled properly, especially if there's anything in this plus right here. If there's anything in that plus, that means that there's phonemes in your data that do not exist in your dictionary, and you don't want that. So because that's blank, that's a good thing. So now that I've removed those files from the dictionary, if I go and hit up and run this again, can you close, please? It should go ahead and start the binarization. So it's first going to binarize the validation files, and then it will binarize the rest of the voice bank. So I'm gonna let this run for a second. It takes a minute or two, and then depending on the size of your database, and then we will start the training. And I'll show you how to get Tensorboard running. All right, homies. So we are at the home stretch for actually getting training started. Next thing we're going to do is just start the training. So the command for that, and all of this is written out on the DiffSinger repo. But again, I've done this so much that I just have it all memorized. I can probably put these commands in the chat for this. So python scripts-train.py, and then we're going to do, does this one need acoustic? I think this one needs acoustic. I'm gonna actually check on that, hold on. Okay, if you're ever confused kind of about what commands they have, you can always just do the Python, the name of the script, and then --help, and it'll tell you what commands you need. So anyway, we are going to do python scripts-train.py, and then config. It's going to be the same configs as the last command, so configs/tgm acoustic.yaml. And then next we need exp name. And that is the name of the experiment. So in this case, we're going to pretend like, I think, what did I write in the configuration? I wrote, this was, oh, TGM acoustic v1. Okay, so we'll just do TGM acoustic v1. And then at the end, I always put reset. And what reset does is it basically ensures that if you're like resuming training and you've changed the configuration file, it's always going to reload the configuration from where you're giving it and not what it's cached, because the training actually does cache a lot of files and scripts, which is kind of interesting. So we're going to go ahead and hit enter, make sure that it's working, but it should be. And once we get this working, I'm actually going to get Tensorboard running so that we can check the model that it's training. But first, of course, I want to make sure that it's actually training, that the training starts before we do anything else. So the sanity checking data loader, this is just kind of, it's kind of like lubing up the gears for the training in a sense. And so what you see here is just kind of like the training thing. So, epoch 0, that's how many times the entire data set has been trained, the percentage of how we're at, how many steps of training are needed until the next epoch is hit, the time, how many iterations per second, and then a bunch of numbers. And we can kind of go into more of what those numbers mean once we get Tensorboard up. So to open Tensorboard, what we're going to do is click this, which is opening up another window of Conda, and we're just going to reactivate everything. So Conda, activate, ds, test, and then we're going to cd, here we go, cd local env setup, and then cd DiffSinger. Cool. So then this is how I do it personally. I do cd checkpoints and then dash the name of the experiment, which was TGM acoustic v1. And then to get Tensorboard going, we do tensorboard dash log dir period. Period is just the root file that, or the root folder that we're already in. So it's going to say Tensorboard blah 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 at blah. We're going to copy this link, go back to our web browser, open up a web page, and look at that. This is Tensorboard. So for the acoustic model, every 100 steps or so, it's going to update a point on these graphs, and these graphs are the loss. So aux smell loss is the auxiliary generator, which is kind of like step 1 in the 2-step process of diffusion synthesis. It sounds a lot like Chevio before Chevio got AI, and is basically kind of like the rough outline of the synthesis. What is normal for you to see in these is for them to slowly go down and kind of have like a curve like this. That's what you want. Same with this one. They might jump around a little more, but for the most part, you want the average shape to be going curving downward like that. Batch size is how much you have loaded. You can definitely mess with the batch size in the configuration depending on how much data you have and how much VRAM you have. The higher the better. It'll train faster and more efficiently at a higher batch size. And then this is showing you what the learning rate is currently at. Learning rate's going to drop automatically. That's not really something you have to worry about. And again, I don't really recommend changing anything. So the next tabs you see up here is images and audio. I'm actually going to wait for this to validate once before I continue with this example so that we have something to compare against. So I will see you guys in a minute. As you can see, we're getting really close to validating, and you can see that here by what step we're at, because we're validating every 1,000 steps. So when you see validation data loader, this is what you want to see. This means that it's creating the validations, which is what is going to be seen in Tensorboard. It takes a little bit because it has to render images and waveforms and all that good stuff. And then after it does that, it's going to save a checkpoint. I'm actually going to stop the training right after this, and you can easily do that by clicking ctrl+c while you're while the command line window is focused. But validation's taking a second. Come on, Grandma. And for a normal like multi-speaker model, you're going to have like almost 100 of those, but it only shows 9 at a time, which is really annoying. I wish I could make that bigger. If I can, please let me know. All right, so it's going to say checkpoint saved, and it's going to keep training. But I'm going to stop it because this is just a test model. So, beep boop, we're going to go to Tensorboard, and if we refresh, we're going to see here, this has changed. So how do you read this? Well, this is step 0, and this is the first validation. What we're looking at is a MEL spectrogram of the data. This is what has been generated by the model. this is what the ground truth looks like. And ground truth in this case means the original file that we're referencing, but it is vocoded with the vocoder you provide it. So that the data is kept consistent. And then here is a graph of what is different between the two. And the goal is to get it close to the original. So as you can see here, this is step 0. So it looks like crap because the model hasn't learned anything yet. This is it's like a validation thing. But here, this is the first thing of validation. And, it doesn't look good. It's not going to sound good, but that's because it's only trained for a tiny little bit on a very small set of data. But this is what you expect. And as it goes, as the training progresses, you're going to notice that these two become a lot more similar. And this ends up becoming just like a blank purple square for the most part with a little fuzz, which is, again, what you want. What you're going to see here is auxmel and diffmel. And the difference between those is auxmel is that first generator that generates the audio, and then diff is the diffusion denoising. So as you can see right here, it's really noisy, but that's, again, expected. And if you want to hear it, you're going to go to the audio tab. I'm going to hit refresh real quick. Boop.
And I say you're the bestest, leaning for a big fist, put your favorite perfume on, to play your video games.
So as you can see, or as you can hear, doesn't sound very good, but it sounds like something. So what you see here is the auxiliary, the diff, and then the ground truth. So this is, again, the generator that I just played. The diff is the denoiser that makes it sound good. And this one takes a lot longer to sound good. And the goal is for this to sound as close to this as possible.
And I say you're the bestest, leaning for a big kiss, put your favorite perfume on, go play your video games.
It's you, it's all for you. So yeah, that's how you train DiffSinger locally. Let me know if you want some more guides on kind of how to export the models. To export the model, it's quite simple, but you do have to install an older version of Torch. So it's basically setting it up using Torch, I think 1.13. Don't take my word for it. And then running the export. All of that is on the DiffSinger repo. But for now, we got the training started. We got Tensorboard up and running. So that is where I'm going to end this off before this video becomes an hour long. Thank you for watching. As always, let me know if you have any questions. Thanks, guys. Bye.